Okay, exercise number 9 in the free fall section. This problem reads, Billy, a mountain goat, is rock climbing on his favorite slope one sunny spring morning when a rock comes hurtling toward him from a ledge 40 meters above. Billy ducks and avoids injury. How fast is the rock traveling when it passes Billy? First, let's gather our information. First piece of information is that there's a ledge 40 meters above, so this is our vertical distance. We'll just call it d because we're only dealing with motion in the vertical direction right now. One piece of given in all free fall problems, and it's usually not stated, you're just going to have to remember this, is g. And remember, g does not stand for gravity. G stands for acceleration due to gravity. So g is our acceleration. You notice the units are meters per second squared. If you forget, that's your acceleration. That'll be a good reminder. And in this case, there's one more given. You frequently see these in free fall problems too. The initial speed is 0 meters per second, so the rock was sitting in place and just fell off. If the problem specifically states that it was pushed, up, down, thrown, whatever, then you know that you're going to have a different initial speed. So, what is our unknown variable? It's easy, fairly easy to read. It's how fast. So we are looking for speed, and right away you should recognize which speed we're looking at because we were talking about the initial speed. So yes, that is the final speed we're looking for. Clean that up a little bit. So in order to figure out the equation, notice how I've written all the variables nice and neat. So I need an equation that has the distance, acceleration due to gravity, the initial speed, and the final speed. If I take a look at the equations, we have distance, initial speed, time, acceleration due to gravity. So this problem we do not have time, so that's not going to help us much. In this problem we have final speed, initial speed, acceleration, and time. So this problem we don't have the time. It's we could solve for it, but it's not really what we're looking for. You will notice this one equation has the final speed, has the initial speed, has acceleration due to gravity, and distance. So this has everything we need. The only thing we don't know is our final speed. So this will tell us, because we have initial speed, we have acceleration due to gravity, we have distance. So this one's perfect. Now the nice thing about this particular problem is the initial speed. It is 0, so we can ignore that. Now you might want to look at it and say, hey, we're solving for VF, we don't need to transcribe. Don't fall for that one because that happens a lot. See that little square? You do need to transpose a little bit on this, but no big deal. So remember, to solve, plug it in. Now remember, before you grab a calculator, check the units. In this case, the units on top are meters squared, and on the bottom are meters per second. And if you take the units on the top are meters squared, the units on the bottom are seconds. And if you square root everything, you get meters per second, which is exactly what we're looking for. And you plug everything in the calculator, because I know you know how, and you should come up with 28 meters per second. And what was this again? That was the final speed. So as usual, think about your answer. We got a rock 40 meters off a ledge. That's pretty high. The width of our classroom is about 10 meters, so that's a really good fall. It's fallen about 28 meters per second, which is a little more than 55 miles per hour. So something falling off a 4-story ledge is going to be going about the speed of a car. So this does sound right. It's falling down in the same direction as acceleration, so we should have the same sign. In this case, we worked with a positive, 9.8 meters per second squared. No reason, so our speed should be in the same direction as acceleration, in this case positive. If you want to call down negative, then the acceleration due to gravity, g, would actually be a negative 9.8 meters per second squared. And then we end up with a negative answer here. Of course, now I'm looking at the square root going, wait a minute. Yeah, just don't even bother with the negatives right now. So keep it simple. Sometimes you might have to draw something. In this case, I did not, but there you go. This was problem number 9.